Hello everyone, it is March 15th, 2023. A little tired, so I'm gonna keep this a little on the shorter side. A couple of quick mentions. The GNU ARM embedded toolchain PR is in the works for the Conan Center Index. Now I'm gonna look at this real quick. Now, it's not currently working, and it works just fine without any warnings or issues on my machine when I run it with their hooks that do all their pre-submit checks and stuff like that. But it seems to be breaking here, so I'm not sure why that is, and I can't look at it. So yeah, ooh, update branch. That's really useful. I think that's a little bit new. Nice. Maybe that'll run all this stuff again, and we'll see if anything changes. But yeah, next up, split up the CI from libhal to libhal CI. Yeah, so now all the workflows are here. The purpose of splitting this up from libhal is specifically so that I can keep the releases separated. Problem with having them in libhal is that, well, currently most of the CI systems use libhal from main. It currently still has this issue, or not libhal from main, but CI from main. So we do libhal. Let me zoom in a little bit. Libhal, CI, GitHub, workflows, library, YAML at main. I want to move away from having this just be on main, because then that means we may want to update something in the CI, and to keep some stability, we should probably give these version numbers. So if you make a release or a tag, you can have this reference that tag. You don't have to do it from release. You can just go over to tags and add yourself a tag. Create new tag, which goes to releases anyway. So yeah, that's the game plan. That's the reason why it's separated, and it keeps the all that stuff isolated from each other, because now any updates to libhal are either going to be documentation changes or going to be actual changes to the code. So that means, the version bumps up from that point. Whereas in this case, we bump the version whenever we feel like the CI is at a new state with whatever features it has embedded. So that's why they've been split. Next up, with the Conan 2 changes, there have been some updates to the prerequisites. I think it's honestly not that. I feel like it's actually easier now. So these are all the same, so there's nothing different here. So if you've upgraded to Conan 2.0, you don't have to run any of these. But once you get to setting up Conan, you do have to run this after you've upgraded. You have to run this. There was 2 commands here before, now it's just 1. The other command of enabling, remotes is gone now. And then finally, you have to just specify which profile you have. Before, you had a set of commands you just had to copy and paste, but this time you have to know which system you're running on. So if you have a x86 compatible or processor, you need to, and you're running Linux, you have to run this one. If you're on Raspberry Pi or something like that, you can run this one. M1 Mac, you run this. Intel Mac, so on and so forth. And that's pretty much it. That's what you got to do. Rest of the instructions are pretty much the same. Although if we go over to trying out libhal, ooh, yeah, this will actually, I think this still works, but it's because it redirects to libhal LPC. I'll go over that in a sec. But I do need to update this actually. And now we just have Conan build like we talked about before, and that should pretty much be it. Yeah, build, debug, yeah, that's all in the right spot. So it's just this up here that needs to be changed. So yeah, that's that. And then the last little area here, it's been a while, a long while. It's been a long journey, but we finally got a boost leaf into Conan. They agreed that it's okay to have boost leaf on Conan. There's a warning posted there saying you should not mix this with normal boost. If you do use boost, you should just use boost in totality. You'll get this in there. But if you put them separately, there could be some finicky, there could be some weirdness. But this is so if you just want to use it on its own. Actually, if you look at this, how long has it been since I made the original PR for this? Oh, boost leaf. Let's do leaf. Oh, goodness. Boost leaf? No. Okay, if I go here, and then I go here, yes. December, okay, so that's in December 2022. That's March. Okay, it's not that long. It's maybe 4 months or something like that, or close to. Yeah. So yeah, 4 months worth of work, and now it's finally on there, and now people can use it just by adding it onto their Conan file txt or their Conan file.py. All right, next up, Roadmap to market readiness. All right, so these are all of the assignments or all of the items, drivers that we want to have available for basically to be able to bring this thing out to the public. Yeah, so we want to, so I'll just go down the list. Add in a storage interface because we don't currently have an interface to represent storage. Storage can be RAM, it can be flash, it can be eMMC, it can be a hard drive disk, it could be some SPI flash, it could be some NOR flash, NAND flash, whatever type of flash. It doesn't really matter. We abstract that information out. So yeah, so we have storage interface. I want to add in a state of charge interface so that we can have something that records how charged up a battery is, or even capacitor, whatever you want to represent. It says add linkers and components. What is this? Oh. This actually I don't think is necessary for this one. I'll actually close this one out. Does she add this for the other ones? She might have. Yeah, she had it for the... Technically this works too here. Yeah. Okay, cool. Yeah, so I'll go into that in a little bit. But basically, I'm actually going to delete this one. Okay. All right, so... Yeah, so a couple of things. I want to be able to support the NRF24L01. It's an extremely common wireless communication board. You find them for super cheap on Amazon. I think actually there's a link here for it. Yeah, and then you get 4 of them for $8 basically. So $2 a pop. That's nice. That's why they're so popular. They're so cheap and they're everywhere, and they look like ESP8266s. They are not, in fact, those. Although it will pop up in the same spot. Oopsie. All right, so there's that. There's some display drivers. This is the one that's on the SJ2 board. This is actually the LED matrix stuff. Yeah, so it's basically the NeoPixels, except these ones actually have a clock line, meaning that you don't have to worry about having your timing be very precise. I prefer those over the other NeoPixels, the single wire ones. We have some distance sensors, some sharp distance sensors, a LiDAR sensor. We have device driver or peripheral drivers for the GD32V, which is a RISC-V board. I want to make sure that we support RISC-V. I guess in order to kind of bring this up, the whole idea of the marketplace readiness, kind of what we're looking for is support a couple of devices that we know people are very common. So that would include the RP2040. That would include this device here, which is the the Teensy 4.1 and 4.0. This device is very much a clone of the STM32 F103, except with RISC-V. So that would bring us into the RISC-V realm, which I'm hoping to do sooner than later. We're also going to support the STM32F1 because it's part of the Blue Pill series, and it's that Blue Pill board, and it's very cheap and available. A lot of people like to use it. The STM32F4, that is when people want to level up above the Blue Pill. That's where they usually go. So we want to support them as well. We want to add in some more IMUs. We want to add in Linux support because that's really going to show that you can bring your project from Linux and bring it over into an MCU, which I think is going to be amazing. But if you discover that your MCU is not going to do it for what you need, you can also bring that same code and bring it over to Linux. So having that portability is going to be really nice. One last driver for LPC. A couple of PCA drivers, which are going to be really nice because they represent the ability to take a driver and implement multiple other drivers out of it. So for example, you pass it one I2C and then you get out 4 or 8 or 16 ADCs. Or you pass an I2C and you get multiple, and maybe an I2C and an interrupt pin, and you get multiple output pins or input pins or GPIOs. Here's me talking about the RP2040 again. It's a very popular chip. A lot of people know about it. It's very cheap. It's fixed price, but people will pay that. I did do some work in porting it over. We had a video of that. Actually flashing it though, so I got something building, so that's at least fine. But I wanted to prove that it could actually work on real hardware. Funny enough, it's actually a lot harder than I thought. So a little side note: the RP2040 does not support Normal debuggers, you need a debugger that has a thing called multi-drop in it, which allows you to control multiple cores, but usually those devices allow you to connect to a single core. Most devices that are multi-core. This one does not allow you to do that at all. Not even like a main core does not allow you to do that. So I got to figure out how to debug and work with this guy, but I'm probably going to shelve it for now unless anyone has any particularly up close needs for it. I believe Adrian, one of our members, one of the contributors, is working on getting the Teensy set up, and I know he has some particular use cases for this. So we'll probably focus on this as well as the STM32F103. But besides those, all the other ones will probably be like, if anyone wants to work on them, they can, but we're not going to put too much emphasis on those ones. I think another fun area here is going to be all the soft drivers. A lot of them are generic motor driver type things, such as, or like just actuator type things. Like we have a buzzer, we have a directional speed motor driver, we have an RC motor driver, we have a RC BLDC motor driver. I'm sorry, this is a servo driver. Generic SD card driver, a linear potentiometer driver, a voltage sensor, which is basically just, an ADC coupled with information about what the voltage maximum should be. Bitbang SPI, Bitbang I2C, which I believe Gene wants to work on this one. So let's actually see if Gene is on this list here. No. Oh, so I think it's Fluffy. Yeah. I'll add Gene to that one. Soft stepper motor implementation, and then soft dual motor implementation, and then also offset servo. So, so that's the soft drivers here. And then STM drivers for the 10X, and then also for the 4XX series. And that's pretty much everything. So I think in total there are around 80 drivers, and maybe some additional work for supporting certain things. So for example, like adding linker script and components. So yeah, that's pretty much that. Once we have this, we have everything we need to be able to showcase our like libhal to the world and say, hey, here are things that we support. You can start playing with this now. So we hit that level of usefulness to the community, but also we'll really show our power and our capability and what we can do. Along with the robotics project being a really good project to demo the technology, also having all these different tools here, because that's what really people are going to be looking for. They're going to look for, okay, cool, you have this really cool, compatibility layer, but do you support anything? What's using that? What can I play with? If they have anything to play with, they're like, okay, that's cool, but I can't see it in practice. So that is the showcase readiness and market readiness roadmap. Now, next up, we have the Cortex ARM chip bring up. This is basically my little tutorial. I made it a couple of days in the morning. And it's split up into chapters, and you can basically go from setting up the library. So even like when you take something from libhal library and from there building up the rest. I'm probably going to make another repo just for target libraries as a template. So you can make a target library, you can make a device library, and so on and so forth. I'm also looking into ways to automate some of the processes here so that when you give the repo a name, it would automatically go through and set up the entire repo for you so that you don't have to do all the extra work. It'll create the single component that you can kind of build from there. I think with that, it would make building these things out super snappy. But yeah, this little 30-minute tutorial goes over how you go about supporting a driver or a microcontroller. And in this particular case, it's the RP2040 that I chose to go through. Highly recommend watching this video to see it if you want to do it. It's actually, once you get through the 30 minutes here, doing it should be a lot faster. And on top of that too, we also have another one for the Raspberry Pi Pico bring up. So here I go over specifically how you go about bringing up the Pico. And the reason why it's a little bit more interesting compared to the normal RP2040 is that the RP2040 doesn't have any flash memory. You have to attach it. So the amount of flash memory that it may have depends on the device. So that is also a thing. Just an FYI, I was not able to flash it. I did get something on there. I was able to load it on there, but I couldn't debug it, and I don't have any drivers. So what I would normally do is open up the debugger, flash it, or load it up through the debugger, or whatever else I'm using, and then get it into main and step through the code to make sure I can step through the code. Like step through the code and I see the code's actually doing something, then I know that it's actually working. Just simply need to add some code. I can inspect memory and that. I can inspect memory and that kind of thing. And the final last items here is that I trimmed the names for some of the repos. So libhal LPC 40xx is now libhal LPC. Same thing with the following two. The main reason for this is that basically I realized I shouldn't just limit this repo to just this. I think it'd be nicer if we can kind of consolidate a lot of these. Especially because there's going to be a lot of like stuff between these two. It's not going to be too much, but the drivers are going to be very similar, and they can potentially utilize the same stuff. So rather than having, 15 different LPC related repos, you have one that has all the LPC stuff. And I think that's still paying for what you use, even if you only use one of them. I think everything's close enough. Same with SCM, same thing with MPU, which MPU is probably going to be merged into libhal IMU anyway. So we'll see if I feel that the IMU one's getting too big or needs to be split up into its own pieces or stuff like that. But we'll see how things come out. Then finally, we have some new repos. In order to support the new prerequisites, we had to make a repo called, not had to, but like I made a repo called Conan config where I placed all of the configuration files. I could actually show you these now. Just do Conan config. And here we have, what type of, are you ARM or are you x64? You go in there, then you figure out, are you Linux? And you go to default. So when you run this, when you run that command in prerequisite, it takes this and installs it into your Conan as the default. So you can run from there. Conan doesn't allow for that command where you're able to just kind of individually choose what settings you want. So this is their recommended alternative. So we're following the recommended alternatives. New repos that are currently available, they have not been updated at all. So the libraries are still, based off, they're just based off the templates, but we did make these. So one for the Teensy, one for the RISC-V clone of the STM32F103, one for Linux, one for DRV, the TI, but also I think other companies use the same word as well. Drive motor control drivers. So we have a library for that. We have a library for display stuff. We have a library for distance. We have a library for connectivity. We have a library for USB. I think I'll keep this thing separate for now, and then when I feel like USB is in a good state interface-wise, we can then bring the interface into libhal. And then we also have libhal RP, which is for all the Raspberry Pi type silicon and microcontrollers and that kind of thing. And yeah, that's pretty much it. Any questions?